Today we're going to look at solving radical equations. A radical equation is simply one that contains either a square root or a cube root, but some sort of radical within it. The 5 steps are listed here. First, you need to isolate one radical on one side of the equation. Sometimes there'll be more than one radical. Then you need to raise both sides to the correct power based on the index. And by that we mean the index is 2 for a square root. If we have a cube root, the index is 3. If we have a fourth root, the index is 4, and so on. If there's still a radical left after doing this, you'll repeat steps 1 and 2. And then once all radicals are eliminated, you solve the equation. And finally, check for extraneous solutions to make sure you haven't introduced something when you squared both sides. As we begin here, if I wish to solve this equation, if it's set equal to 0, the first thing I'm going to do is isolate my radical on one side by moving this entire radical to the other side. When I do that, I'm left with the square root of x plus 4 equals the square root of 3x minus 2. Since my radical is isolated now, I can raise both sides to the power of 2. Again, that power comes from the index being a square root, so it's a power of 2. And by squaring a square root, we are simply left with the value under the radical itself. We now have a simple linear equation. I can move my x's so they are on the same side, and I'm left with negative 2x plus 4 equals negative 2. Subtracting 4, I'm left with negative 2x equals negative 6. And when I divide by negative 2, I get x equals 3. In order to check this, I go back to the original equation, and I'm going to plug in 3 anywhere I see an x. I want to see if this holds true. And using my original equation, I'm going to then subtract the square root of 3 times 3 minus 2. And I want to see if this does equal 0. I get the square root of 7 minus the square root of 9 minus 2 is 7, resulting in 0 equals 0. So it is a true statement and the solution works. As another example, if I have a radical that is already isolated, I can simply begin by using the index power to get rid of the radical. I'm going to square both sides, which leaves me with 2x plus 5 equals x plus 7. Again, a linear equation now where I can subtract x from both sides to get my variables together, subtract 5 from both sides, and I end up with x equals 2. Upon checking it in the original equation, I get 2 times 2 plus 5. I want to see if that indeed equals the square root of 2 plus 7. 2 times 2 is 4 plus 5 is the square root of 9, which does indeed equal the square root of 9, or 3 equals 3. My solution is true.